In this video, we'll demonstrate how to create a simple music player using LabVIEW. The program takes a WAV file as input and plays it through your computer's sound device. First, launch LabVIEW and create a new VI. Let's start with the front panel. We'll add a waveform graph indicator to display the real-time music waveform. A stop button to end playback, and a slider control for volume adjustment. Set the slider range from 40 to 100. Rename the labels of the objects by double-clicking them. And hide some of the labels by right-clicking on the object and select Visible Items, Label. Right-click the Y-axis of the graph and uncheck the Auto-Scale Y. Set the range of Y-axis from -1 to 1. Next, we'll move to the block diagram. Each object on the front panel is represented by a terminal here. You can right-click a terminal and uncheck View as icon to minimize its size for a cleaner layout. The program consists of two main parts. 1. Reading the music file. 2. Playing the sound output. LabVIEW provides a set of VIs for handling sound files. You can find them under Functions Palette, Graphics and Sound, Sound, Files. This is Sound File Read Open VI. It opens an existing WAV file for reading. Choose the Read instance of this polymorphic VI and provide the file path as input. The output is a file reference number called refnum, which is used in subsequent VIs. For more details, enable context help by pressing Ctrl-H or clicking the question mark in the toolbar. Hover over the VI to see its help window and click Detailed Help for full documentation. This is Sound File Info VI. It retrieves the sound format information, which will be used to configure the sound device through the Sound Output Configure VI. This is Sound File Read VI. It reads waveform data from the file based on the specified number of samples per read. The output is an array containing the sound waveforms. For stereo files, the data includes two channels. This is Sound File Close VI. It closes the music file specified by the file refnum. Those VIs are connected using the file refnum and error cluster. For sound playback VIs, go to Functions Palette, Graphics and Sound, Sound, Output. This is Sound Output Configure VI. It configures the sound card using the format data from the Sound File Info VI. You need to set the sample mode and the number of samples per channel to set the playback buffer. The output of this VI is a task ID used in later steps. This is Sound Output Write VI. It sends the waveform array to the sound device for playback. This is Sound Output Set Volume VI. It adjusts the output volume. This is Sound Output Wait VI. It waits until all the sound data has finished playing. This is Sound Output Clear VI. It stops playback and releases the buffer and other system resources. Those VIs are connected using the task ID and error cluster. Now, let's place those VIs on the block diagram. Arrange the sound file VIs and sound output VIs in 2 horizontal rows for better organization. We'll use File Dialog VI to select the WAV file. Set the file pattern to star.wav so only WAV files appear in the dialog. To do this, right-click the File Pattern connector, choose Create Constant, and enter star.wav. Since the sound file read VI reads a portion of the WAV file, and the sound output write VI plays it back, we'll use a while loop to continuously read and play the audio until the end of the file is reached or stop button is pressed. Next, connect the VIs together. The sound file VIs are linked using the file refnum. And the sound output VIs are linked through the task ID. All VIs should also be connected through the error cluster to ensure proper execution flow. Let's complete the VI inputs. Connect the sound format information output from the sound file info VI to the sound output configure VI. For the sound output configure VI, right-click the sample mode input, select Create Constant, and choose Continuous Samples. Then right-click the number of samples input, create a constant, and set it to 5,000. For the sound file read VI, right-click the number of samples input, create a constant, and set it to 2,500. This value should be smaller than the one used in the sound output configure VI. Connect the waveform array output from the sound file read VI to both the waveform graph indicator and the sound output write VI for playback and visualization. The volume input of the sound output set volume VI should be connected to the slider control. Finally, we'll define how to stop the while loop. The loop will terminate when any of the following conditions are true. 1. The stop button is pressed. 2. An error occurs. The error cluster becomes true. 3. The end of the file is reached, indicated by the output of the sound file read VI. These 3 Boolean signals are combined using the OR function, and the result is wired to the conditional terminal of the while loop. Now we are ready to test the VI. If you have an MP3 music file, you can easily convert it to a WAV file using any free online conversion tool. In the VI, we set the volume range to 40 to 100 because this provides an optimal range for volume control. If you prefer to use a range of 0 to 100, you can add a range conversion on the block diagram to map it to the current scale. Next, run the VI to play music. Click the Run button. Select a WAV file. Adjust the volume as desired. Click the stop button to stop the VI. When you're done, don't forget to save the VI and name it Music Player. Thank you for watching. If you like this video, don't forget to like, share, and subscribe for more.